All right, guys. Well, let's get started in our algebra or pre-algebra class. Most of you, by now, you should have already picked up your packets for that has the information for the classes or for the work that you will be responsible for the next few weeks. You should have gotten one that looks something sort of like that. Okay, I believe you should have it by now. But for this week, March the 23rd, I believe it is, that we're in, through the 27th, you will be required, or we're going to be going through chapter 18. So chapter 18.1, point 2, and point 3. And we're going to try to get this done this week. All right, so make sure that you have this work due, that is due on Friday. Make sure that you have it done. In your instructions, it says that you must watch the video. That is this one that you are watching. Yes, you're doing great now. You're also supposed to take notes. You are also to read the chapter 18, 18.1, point 2, and point 3, up to that point. Okay? And you will also have the worksheets. You have your workbook. And in each for each section, you will have worksheets that you will need to do, which we usually do in class, but for this time around, you will do them at home. When you come in on Friday, Friday the 27th, this needs to be turned in. You can turn it in any time on Friday. It could be in the morning or in the afternoon when your parents get out of work. But when you turn in your work on Friday, you will need to turn in your notes from the videos and the work from the worksheet for each section, each 8.1, 18.1, 18.2, and 18.3. All right. Below there, you have just a list, just tells you what you are to do and the work that is required of you. And then at the bottom, it says that at the end of the week, we're going to have a video. We're going to be reviewing some of the things that we saw in chapter 17, and also some of the things that we are looking at today, or that we will look at today and in the next few days from chapter 18. Okay, so keep that in mind, and we're going to have fun. Now, make sure you take notes. Like I said, you are required to turn those in. Okay, you are required to turn those in. So we'll begin. Let's have a word of prayer and we'll get started. Father, thank you for the day you've given to us. We pray you help the students to be attentive. I pray you help them to be diligent, even though we're not there to supervise. I pray that they would have enough self-discipline to do the work that is required of them. Pray that you will help us during this time. Keep us safe. Keep us in good health. We ask it in Jesus' name. Amen. All right. So we're going to be looking at glimpses of trigonometry. Now, don't write anything down yet because we are going to do a little bit of review. Now, write this down. In chapter 17, we primarily focused on the Pythagorean theorem. Pythagoras was a Greek mathematician who came up with this formula, and known for other things as well. He moved to Italy, and there he basically founded his own religion. I believe I mentioned that to you in class a few weeks ago. But the Pythagorean theorem says that a squared plus b squared equals c squared whenever you have a right triangle. Okay, and when we talk about a right triangle, we understand that the triangle will have a right angle. See, this is not hard at all. So basically, what the formula tells us is that if I take the square root of that and the square root of this, it will give me the square root of that, the hypotenuse. So this side of the right triangle is called a leg, so is this one. And the side opposite the right angle is known as the hypotenuse. All right, and so we worked on this last week or 2 weeks ago. And so let's just do a quick review, see if you guys remember, and we'll keep going. All right, so let's say that A, the letter A up here is 8 feet, and B right here is 8 feet, okay? If we take our formula, A squared plus B squared equals C squared, basically we are going to rewrite it as so, right there, right here, okay? So 8 squared plus 5 squared will give me what the hypotenuse is, the value of the hypotenuse squared. So if I do my math, I will get 8 squared, so that was 8 times 8, not 8 times 2, 8 times 8. That will give me 64. 5 times 5 will give me 25. I've added those two. I get 89. And so 89 equals to C squared. So basically what I'm looking for is the square root of 89. And when I put that into my handy dandy calculator, I get 9.4. And so the measurement for C, let me go back, for C over here, if A is equal to 8 and B is equal to 5, then C will equal 9.4, okay? And so the formula is very easy. All you have to do is plug the numbers in the right place. All right, but what if we are given the value of the hypotenuse, but we do not have the value of one of the legs, okay? We can still solve the problem, and you can still figure out what the value of the leg is if you have two of the values given, all right? And so once again, we're going to put the values that we have for this triangle in the formula. So I am going to have, and as you can see it right there, A squared plus 4 squared, and that will give me 8 squared, all right? A squared plus B squared equals C squared. And all I have to do now is do my math, okay? So I'm gonna keep my A squared the way it is, okay? I'm not gonna change any of that. 4 squared is 16, 8 squared is 64. And so I am left with this algebraic expression, okay? A squared plus 16 is equal to 64. Now, in solving an algebraic expression, what you want to do is leave the variable, whoops, let me bring it back here, over here. You want to leave the variable by itself. So if I want to leave that variable by itself, I'm going to subtract 16 from this side, eventually canceling those out. And I'm going to subtract 16 from that side. All right, and so when I subtract negative 16 from my positive 64, I'm going to get 48. So A squared equals 48. Hey, look, I got a happy face right here. That's funny. All right, so 48. So I am left with, what is the square root of 48? And that is 6.9. And so the value of leg 8 over here is 6.9. Okay, and so even if you are missing one of the legs and you are given the value of the hypotenuse, you can find out the value of that leg. All right, great. Let's do a, how about we do a, we do an example, or we do solve a problem. All right, let me bring this one over here. All right, so let's say we have here a right triangle. Beautiful, let me close it, there we go. And we are told that the hypotenuse is, oh, I don't know, let's see, this one is 9. And we are told that leg A over here, here's our right angle, right? So the side opposite the right angle is the hypotenuse. And this one over here, we are told that this is, we're going to say 8. What is the value of b? All right, so very easy. All right, so I'm just going to take 8 squared plus b squared equals 9 squared. Now, because we're adding here, it really doesn't matter where I put this value, okay? So I could have put b squared plus 8 squared is equal to 9 squared, okay? These two can be interchangeable. So that really doesn't matter where if you don't put them in the same order that I did. All right, so let's go through the problem, okay? We're going to solve this. So 8 times 8 will be 64 plus b squared. I can't do anything with that because I don't know the value. And then I have 9 times 9 will be 81. All right, so now I'm going to isolate the variable, okay? We're going to isolate the variable, so I'm going to subtract 64 from this side, subtract 64 from this side, and now on this side now, these two will cancel out. I will be left with b squared equals what? Well, let me do my my subtracting here. So this will be 11 over here. So what? 8, 9, 10, 11, no, 7. 8, 9, 10, 11. So this is 7. This will be 7 and 1. That will be 17. And so I am looking now for the square root of 17. Now, you're going to have to look that up because I don't know what I did with my phone. But whatever the square root of 17 is, that will be the value of that side right there. Okay? So this is very easy. It's not, don't freak out about it. But that's how we work with the Pythagorean theorem. All right, great. I'm glad you know that. We'll come back and visit that later on once we do our review at the end of the week. All right, so let's talk about trigonometry. All right, so we're looking at our notes for chapter 18, okay? Chapter 18. So what is trigonometry? Well, the word trigonometry comes from a Greek word, trigonon. It's actually 2 words, triangle measure or triangle measurement. And so that's what the word means, triangle measure. And it deals with primarily with right angles, okay? So trigonometry, it is a very, very old branch of mathematics. The Greeks were the ones who, we can say, perfected this. And the Greeks were very smart. I am a descendant of the Greeks, by the way. That's why I'm smart, too. Anyway, now don't laugh. I see you laughing. I see you laughing. All right, great. So trigonometry, great. Now, we're going to be looking at some terms, okay? So these terms are going to help us to understand what we will be doing throughout the week. All right, so first of all, let's talk about corresponding sides and angles. All right, copy this down. Corresponding sides and angles. You don't have to copy down the triangles unless you are feeling artistic. All right, so when we're talking about corresponding sides and angles, we're talking about sides and angles that represent the same part of the shapes. Okay, so now how do we know that each angle in each side is representing the same side? Well, the first thing you have to do is you need to find the right angle of the triangles. Now look at these 2 triangles here. Where do we find, in what angle or what letter within the triangles themselves, what letter represents the right angle? All right, just look at it. Which one or what letter represents the right angle? Yes, let's see, Oscar, you tell me. All right, Oscar is not paying attention. All right, let's see. Anaí. What? I can't hear you. Speak up. I'm just kidding. All right, B. All right, B, right here. All right, there's the right angle, and here's the right angle. Okay, so everything. So that means that let me see. That this angle here corresponds to this one here. All right, and so this one here will correspond to that one, and A will correspond to that one there. Okay, so they represent the same part of the shapes. So the right angles, okay, so notice B here is this one. C, we have this and this one. And then we have A, which will be this side right here, will correspond to that one right there. All right, so let me erase all that. All right, great. So corresponding sides and angles refer to sides and angles that represent the same part of different shapes. All right, great. Now let's continue. I hope you have that written down. And like I said in another video, if I'm going too fast for you and you need to write stuff down and I'm just moving along a little too quickly, just pause the video and you should be fine. All right, let's continue. Now the next word that we want to look at is the word congruent. The word congruent. The word means identical in form. Identical in form and in a congruent shape or in congruent shapes. All sides and all angles will be identical. Okay. Now, one thing that you have to notice. Okay, let me see. Yeah, right there. Notice in these shapes that we can, the way that we show that the sides or the angles are the same are by using these little dashes here or using the little arch or using the right angles, okay? So whenever you see, for example, we have these two, the first two, this one and this one, okay? This side right here will correspond to this side over here. How do I know that? Because it has the one little dash on that line. All right. This angle here corresponds to this angle up here. Why? Because it has those two little arches. Okay. And so the same thing. This side here has four dashes or slashes through it. It'll correspond to this side over here. Okay. And so when we work with these shapes, that's why you have to keep an eye out for. Okay. For example, this one here does not correspond to that one there. Why? Because this one has two and that one has one dash through that line. So anyway, keep that in mind. All right. So congruent means identical in form and in congruent shapes. All sides and angles are identical. All right, great. Let's continue. Like I said, you don't have to copy down the shapes, even though it will probably help you out. Okay, next. Let's talk about similar shapes. Okay, similar shapes. Now, similar shapes are the same except for their size. Okay, they are similar or they are the same except for the size. So you will, when we're talking about similar shapes, you'll always have one that is larger than the other. Okay, now there are two main characteristics to similar shapes. Number one, their corresponding angles are congruent. Okay, first characteristics of similar shapes. Their corresponding angles are congruent. In other words, they are, as we said up here, they are identical. Okay, so in similar shapes, even though one is bigger than the other, the angles will be congruent, or they will have the same degree. Okay, basically. And the second characteristic of similar shapes is that the sides are proportional. They are not the same length, but they are proportional one to another. All right, now let me just give you examples of this. All right, so let me bring this up a little bit. Hopefully you already have those notes right there. All right, so let's look at these four shapes here. We have shape numero uno right here, numero dos, numero tres, and numero cuatro. Oui, mon amis. All right, pay attention, because you're going to learn Greek. You're going to learn, what did I just speak? French, all right, in this class, other than math. All right. All right, so we have these shapes that are similar. All right, they are the same except for their size. So numbers 1 and 2 are similar. Number 3 and 4 are also similar. All right, let's see this quickly. How are they similar? Well, if we look at shape number 1 here, the corresponding angles are congruent. So that means that this angle right here in shape number 1 and this angle right here in shape number 2 will have the same degree. They will open up, or they open up in the same, they have the same degree value. Let's put it that way. All right, so, and I know that they are congruent, or that they correspond to one another, because I have one arch there and one arch right there. All right, this one down here has 3. Well, this one is congruent to that side right there in shape number 2. Okay, they have the same value, or the same opening degree in this one and this one. All right, and then the last one in angles, I have this one here and this one in here. The value will be the same for those two angles. All right, and then obviously the last one is the right angle right there. Okay, and so the same thing is true with these two triangles, or these two shapes right there. This angle here would be correspond to that one. This one will correspond to that one. This one to this one, and the right angle to that right angle right there. They have the same degree value. All right. So when we talk about similar shapes, when we talk about congruent shapes, both the angles and the sides will be identical. Okay. When we talk about similar shapes, the corresponding angles will be congruent, or will be the same value, but the sides are going to be proportional. Okay. So in other words, they'll be different. All right, great. Now, hopefully you're getting that. Do you understand that? Does anyone not understand? Great. All right. Nobody answered. Nobody said anything. Let's continue. All right, good. Let's continue. Let's go on to continue in your notes. Now, that brings us the fact that we have this the similarity, okay, between shapes. It brings us to a theorem, and we have what is known as the AAA similarity theorem. Now, AAA over here is not talking about that. I don't know if it's an insurance company or what. I think it's like, yes, I think it's an insurance company, but it's not talking about that. The AAA stands for angle similarity theory. By the way, this little symbol right there, that is the sign for an angle. Okay, so when we do this right here, that's a right angle. When we do this here, it's just any angle within a shape. All right, great. So what does the AAA similarity theorem state? It states the following. Copy this down. If all angles in two triangles are congruent, the sides of both triangles will be proportional. Okay? So, again, if all angles in two triangles are congruent, the sides of both triangles will be proportional. Now, the question is, looking at these three triangles that we have right here, are the sides proportional in these triangles? Well, let's look at them, okay? So we have, let's see, we have here this one, and this one. Then we have this one is proportional to that one and is proportional to that one. So they're proportional. Then we have this one, and this one. Okay, so all of the angles are congruent. They are the same in value. So that will tell me that all of the sides of these triangles are proportional, even though they are different in size, okay? Because their angles have the same degree or the same values, the sides will be proportional. Okay, so that is the AAA similarity theorem. If all angles in two triangles are congruent, the sides of both triangles will be proportional. All right. So here we have three triangles, okay? Great, now let's continue. Now another truth about triangles, and you should know this one by now, is that the sum of all angles in a triangle equals 180, okay? So the sum of all of the angles in a triangle, when you measure them out, the three angles will, I almost said three, my gracious, I almost said three, all right, no, the three angles equal 180. They're all of their degrees put together, all right? So, you see here these examples. We have these two right here. You don't have to copy this down. You just need to know that the sum of all angles in a triangle equals 180. But we'll look at this one here. This angle is 100 degrees. This one is 40. And this one is 40. Okay, so that 180. Great. All triangles are the same. All right. Now here we have this angle down here is 105 degrees. If it were a right angle, then we would have a right angle right there, so that would make it 90 degrees. That one, but it's not. Okay, notice that the slope is a little to the left, and so it's 105. But if you take all of those and you add them, you'll get 180. Same with this triangle and the same with that one. Okay, so all angles in a triangle will equal 180. All right, so let's work on this one quickly. All right, let's say we have this triangle right here. We have this angle here is 115. This one is 35. My question for you is, what is the value of that angle right there? All right, quickly, do it in your head. Come on. So you can write out an equation or write out an equation. So we would have x plus 115 plus 35 equals 180, right? So 115 times, let's see, I don't know, somebody's trying to call me. I'll call them back in a little bit. 115 plus 35 is what? 115 and 35, that's going to give us what? 10, that'll give us 4, that's 150. And so that means that this angle up there is going to be 30 degrees, if I did my math correctly. Yes, 3, 4, 150, right? All right, so if you are given the value of two angles of any triangle, you can find the third one. How about this one right here? What is the value of that angle right there? We have one. This one is 75. This other one is 40. So that'll give us what? 115. Yes. And so 180 minus 115 is what? Quick, tell me. That's 5. That's 7, 6, 65 degrees. So this one will be 65 degrees right there. Okay, so the angles, all three angles in a triangle will always equal 180. All right, great. All right, we're going to come back to this. I'm going a little fast because I want to get through this so that you can work on it. All right, the next theorem. All right, we have another theorem. And we have the double A similarity theorem, not double A batteries, no. The double A similarity theorem. This theorem states that two triangles have to be similar if two sets of angles are congruent or are the same. All right? Once again, two triangles have to be similar if two sets of angles are congruent. All right, make sure you write that down. So, for example, we have here these two triangles. Let me zoom in on this first and then you can copy it again. We have here these two triangles. All right, I think you can see them pretty well. All right, good. Now, we have one angle up here. This one is 70 degrees. All right. Now, a question. What is the value of that angle right there? What is that angle? Somebody tell me quickly. What? Dana, what is it? Okay, Caleb? 90 degrees. All right, so 90 degrees. All right. So now this one is 70 degrees. That one right there is 90 degrees. How much is this one? How much is that one? All right, so 90 plus 70, that'll give me what? 160. So this one will be 20 degrees right there. All right, but the question is, are these two triangles similar? Are they similar? Okay, two triangles have to be similar if two sets of angles are congruent. All right, so are they similar? Well, let's look at it. In this other triangle here, it tells us that, yes, we have a 90-degree angle right there. And then it tells us that we have a 70-degree angle there. And so that means that this angle down here is also going to be what? 20 degrees, all right? There is going to be the same as this other one over here. Why? Because I have two angles in this triangle that are the same value as the two angles in this triangle right here. All right, good. Okay, so once again, let's review. Two triangles have to be similar if two sets of angles are congruent. The AAA tells me that if all angles in two triangles are congruent, the sides of both triangles will be proportional. All right, good. Now let's do some work on this. Let's just do some examples so that we can finish off for today. All right, somebody solved that one right there. What is the value of this angle right there? What is it? What is it? Quickly. All right, come on, what is it? All right, so you got the answer. 5, 4, 3, 2, 1. All right, so this one here is 90. The one down there is 20. So that's going to give me what? 110. And I'm going to subtract that from what? 180. Good. All right, so that tells me that this angle up here is 70 degrees. Okay, 70 degrees. All right, let's look at this one right here. What is the value of that angle right there? What is the value of that angle right there? All right, so I have 105, 35. That's going to give me what? 140. 180 minus 140, that one is what? 40 degrees. Good. All right, great. Okay, good. So that's it for today, or at least for this class. Remember your homework. Your homework for this class is worksheet 18.1. 18.1, that is on page 257 and 259 through 259 in your workbook. And it should look something like this, right? Where is it? It should look something like that right there, okay? It starts off with that one right there. Very, very easy. And so, you know, just use your notes to answer the questions. So you'll do 257, 258, all of those, okay, 258, and then 259. And the last question on 259, that one right there, is the Pythagorean theorem, okay? So just look back in your notes. If you have any questions, I would just go over the notes in the video. And if you're still stuck with something, just send me a message on the video. Or just put a comment down on the video and we'll be happy to answer your question. All right, great. So we'll leave it there for today. Hopefully none of you fell asleep through this. Hope you weren't picking your nose or doing some crazy, nasty junk while we were in class and you were being all disrespectful. That would not be cool. All right, so the next video we're going to be looking at 18.2. All right. Love you guys. Hope you guys have a good day. And we'll see you on the next video. Bye-bye.